Hey, AP, Computer Science. I wanted to do one last video because there is something very magical going on here that I wanted to address. And that is the fact that a compiler, and an editor for that matter, are their own computer programs, which means a compiler was also once source code, and someone used a compiler to compile it. It might also be interpreted, but usually compilers are compiled. But just saying that out loud, compilers are compiled, do you sense like the craziness of that? Isn't that amazing? So at some point somebody wrote in source code in a different language the compiler that will support this new language. And if you look into it, you can see that, for example, Java, the Java compiler, and the Java virtual machine were written in C. Yeah, for sure. It was written in C. And it's like, wow. So what was C written in? And you can look that story up too. Apparently it was written in B, which is a bad joke. But no, I'm not joking. There was a programming language called B. And then what was that written in? Right? It just goes back all the way. There's like this family tree of computer programming languages. And eventually it all goes back to the very first person who wrote a compiler. And I don't actually know, and you don't need to know for the AP exam, but at some point, they used to program in zeros and ones. They had punch cards, right? They would punch out these punch cards. I wish I could give more visuals here. Let's go and, I'm already in Chrome. Let's see a punch card for computers. I'll just put in punch card. Yeah, these are them. So it looks a lot like a Scantron form, right? Have you ever done a multiple choice on a Scantron? Let's just look at this. I don't know specifically what brand of computer this was for. Here we go. But yeah, this is like a punch card for you to punch in zeros and ones and instructions. I'm not exactly sure what the format is here, why they have all sorts of other numbers on here. But this is what it would look like, and it would be done in some kind of like machine where you could punch them in almost like a typewriter. And these holes would represent the zeros and ones. And you'd have a stack of them. Stack of punch cards. It's pretty crazy. A program, yeah, look at this. Oh my gosh, these are precious pictures. Like here, this is your program. This stack, it looks like a fat stack of like money or something, right? That could be your program here. There's all these punch cards, and you would fit them into a hopper. Here's this could be like, oh, I'm in battery saver mode. Oh no, we'll just have to talk fast, I guess. So like this could be like, just a simple program. This could be like tic-tac-toe or something, like this huge stack of cards. And like, look at this over here, this lady, she's looking like mighty proud. Look at this, a huge stack. What is this? What is this? This could be like some like insane program, which we would laugh at as like, like some basic thing now. So, that's how people used to program. But at some point, somebody used punch cards to make the first compiler. I actually don't know exactly what that was, but they probably figured out, a teletype interface, so you could have a typewriter-like keyboard, but it would input text. You'd have to write that program, and it would have to have been written with punch cards originally. And then they eventually managed to get the first compiler so that you could type in some kind of, letters to eliminate the punch cards. But that was written with punch cards. And once they had that programming language, then they could build another programming language on top of it. And we just keep extending and extending programming languages because every generation of programming language opens up new doors. They give us new ideas. Even though they all basically do the same work as punch cards, they just amplify our power to translate thoughts into machine instructions. You could write whatever was the best game you can think of. Your most favorite game, the most modern game, the most expensive game could be written in punch cards. It could theoretically be done, but it's just so bloody inefficient. Like it would take to make, we're talking about NHL, 2K20 or whatever. Like, how many punch cards would that be? It would just be like an enormous mountain of them, right? So it's just not feasible. It just takes too long. But once we had those first compilers and built compilers upon compilers upon compilers, we've extended our tools. We've built these new tools. It's madness. It's really quite amazing to think about that each of these programs is in itself a program, and they trace their lineage eventually all the way back to the original compiler that was written in in Punchcards to create these things. So it's just I just think it's so amazing to think about these things. And nowadays you can actually, for example, the C programming language, the most commonly used C compiler is now written in C. Like, just think about that for a second. The C compiler was written in C. It's like a chicken and egg thing. The original compiler was not, of course. So that's the trick there. The original compiler was written in B, apparently. But once they had C, and C was just more powerful than B, it allowed them to express more complex ideas, they then rewrote the compiler in C for C, because C was better than B, and became a more efficient language. That technique is called bootstrapping, by the way. It's like lifting yourself up by your own bootstraps is sort of the idea they're trying to do. I just think it's so interesting. And I hope you found this lesson interesting as well. Remember, this isn't really part of the assignment, this thing. It was just a little bit of an interesting epilogue, if you will. So I'm going to run out of battery, so I better say goodbye. Thanks so much for listening to this stuff. I hope you had a good time. Let me know. I don't know about the comments of the YouTube video. You could comment on the YouTube video. You can comment in Teams. You can ask some questions. You can make some comments, whatever you like. I would love to hear your thoughts on this, because I feel so distant from my class because I'm talking to myself right now. But I know you're out there. I know you're finding this interesting too. Okay, thanks, AP. See ya.